Hello everyone, I'm Hemesh Chadalavada and I currently study in ninth grade. In this video, I'm going to be teaching you the basics of EasyEDA. So let's look at what is EasyEDA. So I searched the Wikipedia page here. So it says that EasyEDA is a web-based EDA tool suite that enables hardware engineers to design, simulate, share publicly and privately, and discuss schematics, simulations, printed circuit boards. So this is basically a platform where you can design and develop various schematics and convert it directly into a PCB. So EasyEDA is a free platform. You can develop PCBs for free. So let's look at the EasyEDA website now. I'm going to go to easyeda.com. So after this page opens, you need to first create an account. After creating an account and signing in, two buttons appear: the EasyEDA Designer and Download. So many people prefer the EasyEDA Online Designer as this contains the latest updates. This is not frequently updated, so many use the online editor only. So if I click on the EasyEDA Designer, this page appears. Yeah. So there are many menus here. So first, you need to go to the project and then click on the new project, create new project. So it creates a new project. You need to click on the title. So what I'm basically trying to do is to create an ultrasonic and an LED system with the help of an Arduino. So when the ultrasonic detects any range, it automatically turns on the LED. So we can name it like ultra LED or something like that. Ultra LED. Yeah. You can even give a description of your project if you want, but I'm just gonna leave it now. I'll click on save. If you click on the save button, it opens a new schematic page. So in this page, you need to add all the components and connect those components with the help of the wiring tools. And based on that, you can directly convert it into a PCB. So first, we look at the various options here. So in the project, it shows the list of all your projects. In the design manager, it shows all the components and nets. I'm going to be speaking about nets of a further in the further part of the video. So there are no components as we didn't add any components to the page. If you click on the EELib, it shows all the components that are pre-built into the EasyEDA platform. As you can see, there are many components. You can see various diodes, headers, resistors. Yeah, these supply flags if you want these connectors too. So, but these do not contain any Arduino boards. If you want any Arduino boards or modules, as you can see, that nothing shows up. That's why we need to use the libraries button. This contains all the JLC PCB, user contributed, all those libraries. So if I click on Arduino Nano, it shows up. You need to mainly look at user contributed as they are mainly used and developed by the users itself. So you need to observe that both the schematic and the PCB should be here. I'll show you a bad example of this. One second, let me look at the bad. Mhm. Mm. Yeah, as you can see, it shows the Arduino Nano. One second. You need to not choose the package which shows none. This is just the schematic. There's no PCB equivalent of this. So you need to select both. With both contains the PCB and the schematic. So this is good. So I'm going to place this here. As you can see, we added a component. You need to use the right click to add a component, and then click on the left if you want to delete it. So yeah, we added the Arduino Nano. If you click on the Arduino Nano, you can change its names and many attributes. I'll use it Arduino. Hmm. If you want, you can even edit its symbol and its parts number if you want. But this is the Arduino, so we don't want to edit any of them. So let's look at the other components. We want the ultrasonic sensor module, right? Ultrasonic module. We'll again look at the user contributed. Yeah, this looks like a good one, but it does not contain any package. This is a bad example of this. We need to look at one which contains all the packages. Yeah, this contains the schematic and the PCB design. These are all the headers where you should connect where you should connect the ultrasonic sensor. So I'm going to click on the place button and then again right click to add the component and left click to delete it. Yeah, I hope this is clear. So I'm going to name this sensor. One second, why is it? I think this is. I'm going to delete this. Yeah, yeah. There will be some errors like this, but it's easy to solve them. I'm going to name this sensor. Yeah, this is pretty clear now. Yeah, the sensor is the HCSR04, right? Yeah, it works. So you can set the size of it according to the PCB. If you want an very precision, you can click on this. It grows to very precisely. And if you want 200, it's just a medium. If you want, we can directly fit in the window. This is the window, and according to that, it's going to fit. As we are using very minimal components, I'm going to just zoom in. One second, I'll just drag this here. And another components we want are the LED, the resistors, and the 9-volt power supply. So let's look at LEDs. I think there are no good LEDs which are SMD and which are not SMD. So I'm going to show you what SMD is. SMD stands for surface mount devices. These are not just these are not normally used for hobbies and students like us. If we want, we can use it, but I'm not going to teach you this now. I'm going to link them at the description. You can look it up. Yeah, these are all the SMD components. THT are the ones which have headers. I'm going to show you them. Which we use the Arduino Nano, not THT modules. Yeah, these have headers at the bottom, so you can directly solder them. Yeah, so make sure that they're not SMDs because we mainly use THT. If we want to make our project small, we can directly use SMD components as I did previously with my smart wristband project. This is a bad example as this doesn't contain any of them. These are a combination. I think there are no good sensors here right now. So I'm going to cancel this and I'm just going to add a header instead of this. And I'm going to show you a trick. So this is a header, male header. If you want more pins, you can directly select them. I just want two for the LEDs. So let's click this. Right click for selecting and left click for deleting. So we'll name it LED1. So now it contains two pins, 1 and 2, but it's usually not preferred to be 1 and 2. We can name it as plus and minus, right? That's why you need to select the edit symbol tool. If you click this, you can change the pin name according to the pin number. Now I changed it and it appears differently. Yeah, I hope this is clear. I'll just move this a little bit far. Hmm. Yeah, this is good. So we need a resistor too, right? We can directly select it from the EE now. So I'll take this resistor and you can change the various values and size here. I'm going to take the basic one and then edit it. So you can click on 1K and then change its name 330 on 330 ohms, right? Yeah, we have the resistor too. And then we need the 9-volt battery power supply. We can directly connect the barrel jack if we want, but we'll connect it via headers to the B input. That's mostly preferred than this. So again, we'll take the header male and then name it 9 volt, and I'll edit the symbol too. Edit symbol. I'll edit the symbol and then as you can see, okay, yeah, it got edited. So all our components required are added into the PCB and we need to just arrange them accordingly. So as you can see, the LEDs headers are in this way, but the boards are in this way. So if we want, we can select the port and then rotate them. I'm going to flip it vertically. Oh no, horizontally. Yeah, as you can see, it's now flipped horizontally. I'll do the same. This is not required as it's directly here. We want the, yeah, we can directly connect the resistors here. Yeah, this is, we've arranged our circuit according to the nearest pins here, or else we'll flip this here, like this here, this here. You need to just arrange them according to the nearest pins they're connected to. Yeah, I'll just connect this here. Yeah, we arrange them accordingly. Yeah, so we'll just look at what pins do we need to connect. So I'm going to connect the VCC to the 5 volt pin actually. The trigger pin to pin number pin 9 if you want. I'm connecting it to pin 9. The echo pin to pin 10. Yeah, I didn't explain you how to connect it, so I just showed you how to do it. So what you need to do is to select the wiring tool, the wire tool, and then you need to look at the header which you want to connect. So this is, if it shows the red dot, as you can see, this is the red dot. If you choose the red dot, it means that it's connected to the pad, and then right click it and then drag it to wherever you want. So if you want to add a bend in the diagram, I can just directly do that and then directly connect it to the pin. I need to right click the mouse again to connect it. As you can see, I hope it's pretty clear now. They're connected now. If I move this, that also moves. So we'll connect the resistor in the same way. We need to just right click on the header and the right click on the resistor. They're connected now. Now what I need to do is sometimes the resistor's negative is very far from the Arduino Nano's board. So as you can see, this is mainly not connectable as I need a very large wire to do that. So what I can do is I can directly use this pin, which is the net flag VCC. So if I click on the net flag VCC, it something like this appears. So I need to just connect it to the VCC pin, and now they're connected as you can see. Yeah, now it automatically connects to the VCC pin here, but on one condition. You need to add the net flag here too. Net flag here and then connect it. I'm going to flip this. Yeah, now I can just put it here and then drag it. See, both are connected now. Both are now automatically connected. I can do the same for the ground pin too. I'll take the ground one and connect it here. I can just make it a little bit. Yeah, now I need to connect all the grounds. Yeah, they're connected. Yeah, we need to connect the ground of this too. You can even change the wiring according to the schematic if you want. So once if you created, it is very easy to change it again to its previous mode with the help of the redo button. Or if you want to make any specific changes, it is also the EasyEDA is a very flexible platform. You can do that. So I can just connect this V in here. Oh, 1 second. I'll just Control Z for undo. I'll just connect this plus again. Control Z. Yeah, here and I'll connect it to the VN. This is just the basic circuit of Arduino. I hope many of you know it. So I forgot to connect the ground net flag to the ground pin. So let's do that. I'm going to flip this first. I'm going to flip it horizontally. Yeah. Now the ground got connected. I think it's connected. Yeah. So if I want, I can even connect this ground. But if it's not that much, yeah, I'll connect it too just to show you guys. It's not required if you want, but if you are using many ground, if it's a very complex circuit, it's recommended to connect all the grounds because then it will be easy for you to connect it. So I think my circuit is ready now. I'll just fit in the window and then yeah, I think everything is done. If you want to check each and every connection, you can just hover it and then look at its connection. You can even take a screenshot and print it out and verify each of its connection. Mm. Yeah, this is the basic circuit. So then you need to save it. Yeah, after saving, you need to click on this button. It looks like a PCB, right? So you need to click on it and need to press convert to PCB. You need to no keep going. You need to press it no keep going. Nets are not required for our project as it's very simple. They're not even required for many complex circuits as every pin is not used in every component. Yeah, so I click this and I want to flip it again. Yeah, I'll make it this. Make sure that the main IC or what you're using should be in the middle as it's easy for everything to connect in that way. So I'm going to place the ultrasonic sensor based on its nearest connection. 1 second, I'll just flip this. Rotate left again. Yeah, I think it's good now. Hmm. Yeah, based on that, you need to connect every pin of it. This is the LED, right? I click this and then go to the resistor. Yeah, and then place this the 9-volt battery connection to rotate right. You can even change the size of the PCB. You need to click it and then change its size, but it's okay for us right now. Yeah, we can even make it smaller, but I'll just leave it for extra connections. So as you can see, it shows another page which is the layers and objects. A PCB usually, when we develop it, usually contains two layers, the top layer and the bottom conductive layers. I'll show you. PCB layers. Oh, I spelled it wrong. PCB layer types. PCB layers. Yeah, I'll just go to PCB layers. Yeah, when you look at PCBs, I'll just go to two PCB layers. Yeah, I'll show you one thing. Hmm. Yeah, as you can see, these both are the same PCB, but one is showing the above layer and the bottom layer, as you can see. So you can connect in both ways if you want, the bottom layer and the top layer, the top and the bottom layer. So you can yeah, I need a better diagram for it to for me to explain. Yeah, this looks good. As you can see, it contains of two layers. This is the top layer. The solder mask is the color of the PCB, basically. I think this is not that clear. I think you can understand that. The top layer yeah, now yeah, the top layer contains the top connections. Means it's similar to a normal PCB which we make at home. One contains the top wiring and the other contains the bottom wiring. I hope you understand this. Yeah, the core is just the metal which we use, and this is not required for us now. Just remember that it has two layers and you can use both of them for wiring. So sometimes you even want to add text and other things in the PCB. That's when you use the silk layer. The silk layer is used to add text and other things in the PCB, text and icons. So now, as you can see, these are not very well displayed. So I'm going to click on the top silk layer and I just move it somewhere. Yeah, like this. Yeah, I just select it and move it somewhere where it is clear to see and get to know each of them. Yeah, I'm going to click on fit in window again. Yeah, I'll just change this here and I'll flip it. Rotate. Yeah. Yeah, I think it's good now. Hmm. Yeah, this is our basic BCB and PCB and setup right now. Yeah, if in case if you want to add any text, you can click this button for the images if you want. You can just click that and type in the text and change its attribute. It's very simple to do that. So now I'm going to just focus on the wiring of the PCBs. As you can see, these are not connected right now. These will just show where the PCB needs to connect. These are known as the rat lines of the PCB. This is showing that this needs to connect here, and this is showing that this needs to connect here. So it's not proper. It's not connected, and it's just showing us where to connect the PCB. So a PCB in our case, which is the through hole components, which we are using through hole components with headers. So we basically need the bottom layer. We basically use the bottom layer. If the wiring in the bottom layer is not enough, if there's not enough space for more wiring, you can use the top layer too. Yeah, so if you click on the wire button, which is the track button, if you click on the track button and then on the bottom layer, you can now click on any of the connections like this. It shows the PCB where to connect. I'm going to connect it in the shortest way possible. As it's very far, we don't have much to do. Yeah, as you can see, it gets connected. It's just the same like schematic, the wires in the schematic. Right click to drag it and then left click to stop it. I'm going to do the left click and it stops. So now we want to connect the echo pin. Echo pin directly straightly goes here, and I'm going to do the left click. Yeah, left click. This here again, left click. The VCC needs to go here. I'll try to make it pass through the headers here. Sometimes it may not be possible as it's colliding. I'll try to make it work. hmm Okay, then we'll do this later. I'll explain you how to do that in case of this. I'm going to delete this. First, we'll do the simple ones. As you can see, this is good. I'm going to select the track tool, connection here directly, and then here, and then directly here. hmm yeah, this is also easy. We directly connect here, and we directly connect here too again. So, what are left? So, there are three connections left. We can directly connect this here. Hmm. If you want to drag this here to this, this is not drawing us. Both of these are colliding. If you want, we can directly do it. We can turn this around everything and do like that. It's possible, but I'm going to show you a simple way. So this is the bottom layer, right? We can select the bottom layer and then drag this here. As you can see, these both are different layers, so you can draw on top of that. So I'll do the same here like this. I'll go over here like this, like this. Yeah, and then I'll put it here. So as you can see, our whole PCB is developed. I'm going to add some text like this. As I told you earlier, I'm going to add simple text. Yeah, you need to click on the right button of the mouse to add a text icon and then left to delete it. So if I click on the text, I'll need to remove all these. I'll put the text as ultrasonic LED. Oh, that's a funny name. Ultrasonic with I'll use camel casing. Ultrasonic. Oh, it's capital always, I think. Ultrasonic. I'll use camel casing as it's mainly used in the programming world. I don't know why am I using it with the PCB. Ultrasonic with LED. Yeah, this is good. Now we need to select and put it anywhere here. Here you can even add a similar image or icon here. So our PCB is done basically. So you need to save this. It gets saved online. So if you want to check your PCB how it looks in real life without actually ordering it, you can click on this camera icon and then you either choose the photo view or 3D view. I'm just going to choose the 3D view right now. See, as you can see, this is the top layer of all of them. You can see the connections, what we connected on the top layer. If I go to the bottom layer, as you can see the rest of the connections. This is a more this is more easy to understand, I hope. See, this connects here. As you can see, if I go to the other line, these both intersect, but both are in different layers. So that's not a problem. I'll show you the photo view now. As you can see, this is the top side of the board. I think this is more clear to see. And if I go to the bottom side, it shows the rest of them. Hmm. So now our PCB is done. So what if we want to directly order it, or if we want to download the file? So then you need to click on this button, which is the download the Gerber file, generate fab Gerber file. You need to click on yes, check DRC. It will check whether any errors are there. As you can see, there are no errors here. If we want, we can directly order the PCB from JLC PCB. I think this is blocked for now. I'll show you later how to do it. Or you can click on generate Gerber. I'm going to generate the Gerber file. As you can see, this Gerber file is being downloaded. And now I'm going to show you how to order the PCB. our Gerber file is downloaded. Means our PCB is completely done. We just need to order the PCB if we want. As you can see, this is the tutorial of EasyEDA. So EasyEDA works with JLC PCB. JLC PCB is also a very good PCB ordering platform. I'm going to go to jlcpcb.com. You need to click. You need to again create an account. So there's a problem right now due to the COVID-19 outbreak. But you can simply do that if you. I'll show you how to do an order in case normal case of ordering a PCB. So you need to click on quote now. First, you need to create the account and then click on quote now here. So I'm going to close the main tab. It opens another tab. You need to click on add your Gerber file. So you need to add your Gerber file. I think mine is in the downloads. Downloads, yeah. Sort. Sort by. Yeah. This is our Gerber file. So if I upload this, it shows the PCB, how your PCB actually looks. You can select the various options. As we have two layers is enough. This is the dimensions of the PCB. You need to not change that. You can change the quantity, how many you want. So it's basically the same. The thickness is 1.6, which is recommended. You can change the color too, but it impacts the price of the product. Yeah, so green is mainly used as it's cheap to produce and very easy to produce too. You need to put this here. The copper weight should also be in 1 ounce. No, yeah, this is just the designs if you want. You can even add multiple designs in one. You can, if you want, you can add many remarks here. Yeah, that's basically the PCB. You can just save to cart and then order it. So now I'm going to show you the various source on how to where to look at EasyEDA if you want, if you have any doubt. You can look at EasyEDA troubleshooting. Yeah, you can click this here and it opens the form of EasyEDA. 1 second. Yeah, this is the form. Yeah, this is the forum of EasyEDA. You search any problems. I mean, others can also face the same problem as you. So you can look it up. This is the best source for EasyEDA. Many YouTubers also make tutorials for EasyEDA. I'm going to show you some of the good ones. EasyEDA, EasyEDA, yeah. I have good. Yeah, Electro Noobs has good one. This is a good one. I'll just mute this. And the one which actually I learned EasyEDA from is I'll just close this. This is a good tutorial. EasyEDA by Electro Noobs. There's also other tutorials by Great Scott. This is also a very good one. You can look at Great Scott. This is by Great Scott. Yeah, this is by Great Scott. This is pretty good too. The one which actually I learned is from by I think PCB. It's called PCB design. PCB designing. I think it shows now. Yeah, I think it's by Easy Homemade Projects. This is where I got to know about PCB designing uh, and mainly about Easy. And right, and 14 then next show. Great. Yeah, this is a great way to learn electronics. So which I recommend to do is to look at learn electronics from learn electronics tutorials, Great Electro Noobs and Great Scott. These three are the best YouTube tutorials which I know. And yeah, EasyEDA forum. So I hope you liked this project tutorial video. So thanks for watching this video. Thank you.